Hey, good morning, everybody. It looks like we've got a few more participants, so I will go ahead and get started. My name is Taylor. I am a certified flight instructor. For those of you who are new, I see a few familiar names in the participants. But anyways, I am a flight instructor. I teach out of Southern California. I have a few students who I teach how to fly fixed wing aircraft. I joined Altitude University last September to help with the Part 107 side of things. So I've been doing these live Q&As for the last couple months now, and then help answer questions in our Facebook group or through email regarding questions or topics on the Part 107 material. If you guys are not already part of the Facebook group, I highly encourage joining it. It's a great resource to chat with other drone pilots or soon-to-be drone pilots, ask questions about the material in the course, or even business practices, how to grow your drone business, equipment, things like that. Today, we're going to be talking about weather effects on our small unmanned aircraft. So we're going to get into a few different definitions. Then we're going to talk about wind and currents. We're going to go over some questions that you might see on your written test, as well as questions that you'll see in our course. And then at the end, we'll open it up to Q&A. So whether you guys have questions on today's material or other topics in the course, I will do my best to answer those at the end of today. If I can't get you a direct answer, then we can chat via email. But yeah, I did open up the chat. So throughout today's session, feel free to throw some comments in there, especially when we get to the question portion of it. You could throw your answers in the chat. If you do have any questions, there's also a Q&A tab as well that you can throw your questions in there. So to start off, just to get some terms out of the way, MSL is going to be mean sea level. So that's going to be our height above sea level. Then we have AGL, which stands for above ground level. So like the definition says, that's going to be our height above the ground. So above the surface as opposed to above sea level. When we're talking about sectional charts, which we have a whole other live session on charts, it's important to note that they're always measured in MSL to measure airport elevations. There will be a few figures that are in AGL, which we talk about that in the live Q&A, and it's mentioned in our course as well. But typically, all the altitudes you read are going to be in MSL. So to start off, we need to be familiar with a few different types of altitude. Now, there's 5 of them. So we have indicated altitude, pressure, density, true altitude, and then absolute altitude. So this first one being indicated altitude, this instrument that you see on the screen is called an altimeter. So this is an instrument that manned aircraft use in their aircraft. So whether it's a helicopter or airplane or whatever, to give them their indicated altitude. So when we did the METAR session last week, we talked about an altimeter setting, for example, like 29 or 9 or 2. Well, they would set that number into this little window here. It's called a Colesman window, and it's going to give them their indicated altitude. So this is something that is really just for a manned aircraft. Then we have a pressure, true, and absolute altitude. So when we're talking about pressure altitude, we're also talking about ISA, or the International Standard Atmosphere. So the pressure altitude is like this theoretical level that at this level, the weight of the atmosphere is 2 inches of mercury. Now, when you're studying, you'll probably see something along the lines of the standard pressure at sea level is 2, and then standard temperature at sea level is 15 degrees Celsius. But as you can see in this picture, they call it the standard datum plane. So like I said, it's that theoretical level. Now, this is going to be how your aircraft feels like it's flying. And that's because our air pressure changes for a lot of different reasons. And that's where we get that number in the last slide to help us calculate the pressure altitude. But it's basically going to be what our altitude is above this theoretical plane. Then we have true altitude and absolute altitude. So our true altitude is going to be what our altitude is above sea level, as opposed to absolute altitude is going to be our altitude above terrain. An easy way to remember that's just absolute and AGL both start with A. I like silly little ways to remember these terms. But you can see in this graph here, our true altitude is going to be above our sea level, but we could be flying over terrain, and that would be what our absolute altitude is. Okay, then we talk about the density of our air. So as we're flying in the Rocky Mountains at high elevations in less dense air, the performance of our aircraft decreases. Why is that? I'll leave that open to the chat. Maybe some of you who have already gone through a course might know the answer to this. So give you guys a second if you want to throw your answer in there. If not, we're going to talk about it in the next couple slides, but I'll give you guys a second. So at high elevations, less dense air, that directly affects our aircraft performance. Nobody's brave enough this morning. All right, so what we're talking about is density altitude. So the FAA definition of density altitude is pressure altitude corrected for non-standard temperature. The reason we talk about density altitude is because high density altitude results in less performance from our aircraft. Now, there's three main factors that are going to contribute to high density altitude. One being altitude, two, temperature, and three, humidity. So with altitude, as we increase in elevation or altitude, the air pressure decreases. I just pulled up like a little graph so you guys can see in a column of air. This is kind of a small picture, but you can all these kind of show this or depict the same thing. So in a column of air, you can see here at sea level, we have all these dots here. Those are our air molecules. And as we increase in our altitude, they show the top of the atmosphere here. We have less molecules there. So our air is less dense in that column of air as we increase in altitude. So that's the major one that's going to affect our density altitude. And then we have temperature. So if you were to take two columns of air, and in one column you had cold air, and in the next column you had warmer air, what you would see is in that cold air column, those molecules are going to be really compact and close to each other, making the air dense. When the molecules heat up, they start to bounce away from each other. So in that column of air, they're going to be more spaced out. So they're not as condensed as our cold air. So that same, volume of air here, we're going to have less dense air because those warm air molecules are kind of more spaced out from each other, not allowing as many air molecules to be in that column. Then we have humidity. So humidity is a factor in density altitude because our atmosphere is mainly composed of oxygen and nitrogen. Now, if you were to take the atomic mass of oxygen, of nitrogen, and of water molecules, you would actually find that water is less dense than both oxygen and nitrogen. So again, if you had a column of air and you pushed out some of our air molecules and replaced it with water molecules, that overall mass or that overall density is going to be less dense because the mass of the water molecules are less than that of our air. So overall, it's going to make our air less dense. Now, why does this matter? Well, because it's going to directly affect how our aircraft is performing, because now we have less less air molecules flowing over our props, for example. So our propellers or airfoils are completely dependent on air molecules flowing over them in order to develop lift. So if we're decreasing the amount of air molecules that are flying over our airfoils, then we're decreasing our performance. So the key notes to take away from this is the characteristics associated with high density altitude occur at higher elevations, higher temperatures, and higher humidity. And then on the opposite side of that, a lower density altitude occurs at lower elevation, lower temperatures, and lower humidity. Then we could talk about the stability of our atmosphere. So when we're talking about the stability, you can think of it in terms of the ability of our air mass to resist vertical movement. So if we're talking about a stable atmosphere, you can expect stratiform clouds. Now let's see if we can I should have included a picture in it here, but stratiform clouds, just so you guys can get a visual. So stratiform cloud is going to be like this blanket of clouds, like you would see here, right? They have little to no vertical movement. It's just like a thin blanket of clouds. Now, you can also anticipate poor visibility and steady precipitation in a stable atmosphere because we don't got a lot of wind going on there. As opposed to an unstable atmosphere, we have, well, sorry. Cumulus clouds. We can anticipate cumulus clouds. So those are going to be our big poofy clouds. Now, as you can see, this has quite a bit of vertical movement. So in unstable air, it's less able to resist vertical movements. You're going to get these big poofy clouds. Now, also associated with that, you can anticipate turbulence, great visibility, and then showery precipitation. So those are kind of like the key terms or characteristics that you'd probably see on a test. The only thing I would include in each one of these is in a stable atmosphere, you're probably not going to experience, it would be like little to no turbulence. And in an unstable atmosphere, you would definitely anticipate some turbulence. Okay, wind and current and some terminology. So when we're talking about ground topography, we're just talking about mountains or large buildings. Convective currents are going to be currents created when liquids and gases of different temperatures come together. So you have two air masses of different pressure or temperatures, and they come together, creating convective currents. We have an updraft, which is an upward current of warm air, and then downdraft, downward movement of air. So in this picture here, you can see it says sea breeze, but what this is depicting is when we're talking about heat exchange. So our land is very quick to absorb heat, and it's also very quick to give off that heat. As opposed to our ocean or an area of vegetation, it's very slow to absorb the heat and then also very slow to dissipate that heat. So during the day, our land is a lot warmer than our ocean. So we have warm air over the land and warm air rises. And it has to be replaced by something. So it's being replaced by cold air from over the ocean. So we have this warm air that's rising. As it's rising, it's getting pushed over the sea and it's starting to cool off. Then it starts to sink as it cools. And then we get this little circular motion here where that cool air again is replacing that warm air. The air warms up, it rises. It travels over, it starts to cool, and then it starts to fall again. So we get this little cycle going called a sea breeze. Now, the opposite is going to occur at night because, like I mentioned, the land heats up really quick, and then it gives off that heat really quick. The ocean's going to absorb that heat slowly and dissipate it slowly. So at night, the air over our ocean is going to be warmer than that air over our land. So now we've just got like an opposite cycle going. So we've got warmer air over the ocean. That warm air rises and is being replaced by the cold air from over the land. Traveling over the land, it starts to cool and then it starts to sink. And now we've got this cycle going on called a land breeze. So you would anticipate a sea breeze during the day and a land breeze at night. When we're talking about wind associated with a mountain, we have a windward side and a leeward side. So the windward side is going to be the side that the wind is traveling up. So we've got this smooth wind, hopefully smooth, somewhat smooth, wind flowing up this side of the mountain. On the back side of it, that's going to be called our leeward side. So you can see that that's where we can anticipate very turbulent air. It's no longer smooth air. It's not going to stick to the side of the mountain here. It's going to flow up to the side of the mountain, and then on the back side, it just kind of drops off and creates turbulent air. So we've got windward and leeward side. Okay, some things that we need to be knowledgeable of. One is wind shear. So the definition of wind shear is a change in direction or velocity of the wind at any altitude. I can, at the end of this, show you guys a resource to find low-level wind shear or like forecasted or reported low-level wind shear, because that would be important for us to know since we are operating our drones close to the ground. Now, wind shear can happen at any altitude, but we definitely want to be knowledgeable of the wind shear that's happening closer to the ground. So I'll show you guys that resource at the end of today's session. And then a microburst. So microburst is about like a 5 to 15 minute really intense section of weather that includes really strong updrafts, downdrafts, intense rain. It's very dangerous. All aircraft are advised to avoid microbursts. It's very short-lived, but you can lose up to a couple thousand feet per minute in altitude in a microburst. But yeah, so just one of those things that the FAA advises that we obviously avoid, because that could put us in a very dangerous flying situation. Okay, some questions that you might see regarding weather. This one's about the stages of thunderstorms. We didn't talk about the stages today, but if you have already gone through a course, then you've probably seen this material before. So a thunderstorm will reach its greatest intensity during either the dissipating stage, the mature stage, or the cumulus stage. I'll let you guys throw your answers in the chat, and then we'll talk about it in each stage. Awesome. Thank you, Brian, for the participation. All right. So, oops. There we go. So our answer here is the mature stage. So our thunderstorms have 3 stages, the first one being cumulus. Now this is the first stage where you can anticipate updrafts. Then we have the mature stage, which is going to be that middle part of our thunderstorm. It's the most intense, characterized by updrafts and downdrafts. You know that the mature stage has begun once we see precipitation on the ground. And then lastly, we have the dissipating stage. That's the latter end of our thunderstorm when it's starting to dissipate. And you can anticipate mainly experiencing downdrafts during the dissipating stage. What effect does high density altitude have on an aircraft's performance? So going back to that slide we did a couple minutes ago, our high density altitude is affected by altitude and temperature and humidity. So this question is asking, what effect does high density altitude have on our performance? Awesome. Thank you, Brian. Yeah, exactly. So our propeller efficiency is decreased. Now, again, our propellers or airfoils are dependent on air molecules flowing over them in order to develop lift. So if we have a high density altitude, that means that that air is less dense, therefore decreasing our propeller efficiency. I've always thought that was like a little confusing, associating high density altitude with less dense air. You would, I don't know, the words make it seem like it'd be the other way around. But anyways, what is true altitude? So we got 6 different types of altitude that we went over today. So what is the definition of true altitude? Anyone wants to throw in an answer? Oh, there we go. So our answer here is B. So it's the vertical distance of your aircraft above sea level. So we have true altitude, which is above sea level. Then we have absolute altitude, which is AGL. So you can think of that as A and A. I don't know. That's kind of an easier way to, oops, go back one question. Yeah, just an easy A and A go together. I don't know. That's the way that I've always kind of remembered it. But yeah, true altitude is the vertical distance above sea level. Okay, while operating your small UAS around buildings, you should be aware of wind gusts that either A, enhance aircraft performance, that'd be cool, B, change rapidly in speed and direction, or C, affect remote PIC visibility. Awesome. Thank you, guys. Yeah, so our answer here is B, change rapidly in speed and direction. So if you think about a wind current, it's flowing, then all of a sudden we put a building right in the middle of it, it's going to disrupt that flow, right? So it might change the speed and the direction of that current. So we definitely want to be knowledgeable of that when we're operating our drones around buildings, because it can put us in an unsafe situation, or even, put others in a harmful situation as well. Okay, what are the characteristics of moist, unstable air masses? So we talked about the characteristics of stable and unstable air. Just to reiterate, when we're talking about the stability of an air mass, we're talking about its ability to resist vertical movement. So that should give you at least an indication on what type of clouds you can anticipate in unstable air. Awesome. You guys are killing it today. Yeah, exactly. So we can anticipate cumuliform clouds and shower precipitation. So again, those are our big poofy clouds. They have a lot of vertical movement. So that would be an indication of unstable air. Wind shear is a sudden drastic change in either wind speed and direction over a large area, direction over a very extensive large area. These are all kind of similar. And then wind speed and or direction over a very small area. Woohoo. You guys are doing great. Our answer is C. So wind shear is a sudden drastic change in the velocity or the direction over a very small area. That's all the questions I had for you guys today. Like I said, I'm going to show you guys, if you've been coming to the sessions, I often refer to aviationweather.gov. And I'll show you guys where you can find forecasts or reports of low-level wind shear. I'm not sure if there will be any right now. But if we go to advisories and then AirMet, so that's for graphical AirMet. Let's see. So this gives us all of our different AirMets, as well as there's a tab for SIGMET. So if you've gone through our weather course, you'd be familiar with those terms, but they're forecasts for certain types of weather. Now, what I like about this site is you can click or unclick these little tabs here. So we're not too concerned about high level turbulence because we're not going to be operating in those levels or at those altitudes. So you can just unclick it and then it won't pop up. So what I'm concerned about is low level turbulence. So I would click this one here, make sure that one's highlighted, and then also low level wind shear. Now, I don't see any low level wind shear ones, but I do see low turbulence. So you can see what time this is valid starting at, and an AirMet is valid for a 6-hour window. And then what time it was issued. So it was issued at 1445 Zulu, valid starting at 1500 Zulu. The severity of this turbulence is moderate. And now the base is at the surface, tops 14,000 feet. So that's a pretty big window there, or a gap there, that you can anticipate you might have moderate turbulence from all the way up to the surface, all the way up to 14,000 feet. So that'd be a good forecast to look at. Like I said, I don't see any for low level wind shear, but there are some from time to time. Surface winds also, so that's good to note. This one again tells you what time period it's valid at, and what time it was issued. And it tells you due to sustained surface winds greater than 30 knots. So that would be really good to know before we take flight, right? Especially if we're operating within 400 feet of the surface. The other way that you could, let's see if there's anything over here. Nope. We got IFR conditions and mountain obscurations. Another tool you could use for this is aircraft reports. So there's also PIREPs, or also called PIREPs, or pilot reports. I could probably guarantee all the ones over here are about clouds right now. But oftentimes you will also see PIREPs for wind shear. So you just click on each of these. It tells you the type of aircraft. To be completely honest, I don't know what aircraft that is. I'd have to look it up. This one's talking about the cloud bases, but sometimes they'll say something like lost 20 knots on short final. So that means that they're pretty close to the ground. That would be within 400 feet of the ground where we're operating our drones, and they lost 20 knots. So that would be something to be knowledgeable of. These are, let's see, we have a few for like turbulence over here too. This is a great website. Most of these charts have legends. So down here you can see our PIREP Legend, if it's like this little green guy, it's light turbulence, moderate, and severe. And then you can click on them. It'll give you all the information about it too. This one's up at 26,000 feet, so that's not going to affect us. But I would take a look at this before you're flying in your region, and see if there's been any reports for low level wind shear, or gusts, things like that. There's like quite a few over here on the East Coast or down south. But anyways, that is all I have for you guys today. I will hang out for a few minutes if you guys have questions on today's material, or if you have questions on anything else from the course. Next week, we are doing Monday at 5 o'clock Pacific time, and we're going over airspace next week. If you guys have any questions throughout the week, you can shoot us an email and I'll get back to you guys, or post in the Facebook group. I try to monitor that every day or every other day to answer you guys' questions. Unrelated question: if the government actually passes a full DJI ban, will that open the door for, I'll tell others I'm concerned about buying a new drone that becomes a multi-$1,000 door shop? To be completely honest, I'm not too familiar with the topic of the ban on that. I can do some research. I think that'd be a good question for the Facebook group. So I'm not too familiar with that case. But if you want to shoot us an email, or post in the Facebook group, that'd be a good topic of discussion for everybody. But I'm not too familiar on it. I'd have to do some research on what's going on with that. Yeah, of course. Wish I had a better answer for you, but yeah, I'm not totally sure. Like I said, some of you guys, I see some familiar names every week. Do you guys have tests coming up, or have you already taken your tests and you just do refreshers? I feel like quite a few people come and do the refresh, use this as a refresher every week. It's definitely material that if you don't use it, you kind of lose it, sort of thing. With my instructing, I have 8 students, and sometimes I get to a lesson where I have to teach a topic that I haven't covered in a while, so even I go back and study all the time. So this is a great resource for you guys to, use as a refresher. But anyways, like I said, I'll hang out for a few minutes. I'm gonna turn my camera off, but I'll still be here. So if you guys have any questions, throw them in the chat or in the Q&A. Other than that, I hope you guys have a great week, and I will see you guys next Monday at 5 o'clock Pacific time.